All right, mathletes, here we are looking at experimental probabilities and probabilities from tables of data. So, the study of probability deals with chance, okay, or likelihood of something happening. Typically, for all these events, we are going to assign a number that lies between 0 and 1, okay, where 0, okay, is an impossible event, and that would be a 0%, okay. Or we could say that something is guaranteed to happen or certain to happen, and that is a probability of 100% or a probability of 1. Remember, to get your probability number here, to convert it into a percent, just multiply it by 100, and that number that was between 0 and 1 will be now a percent that will be between 0 and 100. Okay? So, to each event, we assign an experimental probability by observing the results of an experiment, or a theoretical probability by using arguments of symmetry. So today, we're going to focus on experimental probability. So we either have data already given to us, or we're conducting an experiment. Okay? So, experimental probabilities. So, oftentimes we need to define some common vocabulary that we're going to use here. So the number of trials is the total number of times the experiment is repeated. So if we were talking about flipping a coin, I could talk about, well, what happens if I flipped a coin twice? That would be 2 trials, okay? Or maybe I was rolling dice, and maybe I was rolling dice 6 times, and so that would be the number of trials that I would do it, okay? The outcomes are the different results, okay? So for a coin flip, we have 2 outcomes. We have a head or we have a tail, okay? So when we talk about our universal set here, okay, we have 2 elements, a head or a tail, okay? When we're dealing with a universal set for our dice, okay, the possible outcomes are 1, 2, 3, 4, 5, or 6, and that would be our universal set for the possible outcomes for my dice. Okay. Frequency. So frequency is how many times those happen. So if we repeated a number of trials, I could count how many times I got heads, or how many times I got tails. Same thing with dice. Okay. Relative frequency is of an outcome is the frequency of that outcome expressed as a fraction. So oftentimes we're going to use this equation that a relative frequency is equal to our frequency, how many times that event happened, over how many trials we actually did of that. So let's look at an example here. So I'm dealing with throwing up this cone type shape, and I'm curious if my cone is going to land on its side or if it's going to land on the base. Okay, so do this. I'm going to repeat this thing about 900 about 900 times. Okay, or I'm sorry, 300 times, and we're going to see of those 300 times how many times they land on the side and on its base. Okay, so we see that it landed on its side 203 times, and it's landed on its base 97 times. So the number of trials that we did was 300. The possible outcomes are side and base. Okay. The frequency of that side is 203 because it happened 203 times. 97 was the frequency for the base. So if I want to find my relative frequency, I use my equation of the number of trials on the bottom over the frequency of the event. So this is, typically we will write this as the probability of side is approximately equal to 0.677. Okay, so the relative frequency for base, okay, well, it landed on its base 97 times out of the 300. Okay, so typically we write this, these P kind of says the probability of landing on the base This is our outcome that we were finding the probability for, and we get approximately 0.323. Remember, experimental probabilities can vary from time to time, okay? But overall, if we conduct this experiment over and over, that the more times that we do it, the more accurate that our relative probability is going to be. Okay, so sometimes we're going to be given sets of data, and we were going to want to answer similar type questions. Okay, so here is a list. George loves apples. Okay, he eats them pretty much every day. And so he collects some data on how many apples he eats. So the frequency is how many days he ate 0 apples. Okay, so for 10 days he ate 0 apples. For 1 day, for eating 1 apple, he did that 17 times. 2 apples, he did it for 2 days. Eating 3 apples, he did that 3 times. And 1 day, he just couldn't get enough apples. He ate 4 of them, but he only did it on 1 day. Okay, so first thing I want to know is how many trials did I look at? How many days did I look at overall? So if I add up all these numbers, 10 plus 17 plus 12 plus 3 plus 1, that's equal to 43 trials. Okay, so if I want to estimate the probability that on a randomly selected day, George will eat exactly 1 apple. So I'm going to write the probability of eating 1 apple is going to be so the observed times that he ate 1 apple was 17. That is over the 43 days we observed. And we get an approximate relative frequency of 0.395. Okay? So if I want to know at least 3 apples, so the probability of at least 3 apples, okay? So I think of he could eat 0 apples, would not count because he didn't eat at least 3. Okay, so I want to think 4 apples would be included in that because that's at least 3, and so I'm thinking of that data set there. So the frequency that he ate 3, I add these two together, so I'm going to have 4 over the 43 days that he ate them. And I can put that in my calculator, and I'm going to get approximately 0.093 as my relative frequency. Okay, so that concludes our notes tonight. Please highlight any questions you have and bring them to class tomorrow.